lecture, I will discuss base change formula in a vector space. Suppose B and B dash are two different bases of a vector space V, and if V is a vector in V such that it has one representation in the basis B and we wish to find its representation with respect to basis B dash, then I'll give a formula which is called a base change formula, which converts a representation of a vector with respect to one basis into its representation with respect to some another basis. So before doing that, let's recall certain definitions. So first definition is a basis of a vector space Vf is the set of vectors in V which is linearly independent over F and spans the vector space V. If we give some ordering to it, then it is called an ordered basis. Suppose U equal to U1, U2, Un is an ordered basis for V and V is a vector in V, then there is a unique list of scalars C1, C2, Cn such that V can be written as linear combination of these vectors with these scalars C1, U1, C2, U2, etc. The scalars C1, C2, Cn are called components of the vector V relative to the ordered basis U. Sometimes we shall call the coordinates of V and sometimes it is the components of V. These are the same things. We shall write these components in the column vector and denote this by this symbol square bracket and subscript U. The column vector Vu is called component vector of V relative to the basis U. So here I have written V subscript U is in a column C1, C2, Cn. So here it is important uh, that we shall write these components in a column, not in a row. Now come to a change of basis. Suppose V is a vector space over some field F and B equal to U1, U2, Un is one basis and B dash W1, W2, Wn is another basis. Both are in some order. Let V is some vector in V and VB is this column vector. I have written in a row and this T is transpose of this row. It means it is a column vector. So VB is the component vector with respect to basis B and VB dash, which I have written D1, D2, D and T is a component vector with respect to basis B dash. We wish to know how these component vectors are related to each other. The relation is obtained as follows. So how C1, C2, Cn and D1, D2, Dn are related with each other, this is our objective. Since Ui belongs to V and B dash is a basis of V, therefore each Ui can be written as linear combination of the elements of B dash in a unique way as follows. So U1 is a linear combination of elements of B dash. So this is our B dash. U2 is a linear combination of elements of B dash, and similarly this UN is a linear combination of elements of the vectors in B dash. The system of equations we have written here can be written in the form of a matrix. So this system I have written in the form of a matrix. First column is U1, U2, UN and then this coefficient matrix and W1, W2, Wn. Any vector V belongs to V has following unique representation with respect to two bases B and B dash respectively. So V is arbitrary vector. So with respect to basis B, it has this representation C1, U1, C2, U2 and Cn, U2. And the same V with respect to basis B dash has this representation V is equal to C1, W1 plus C2, W2 plus Cn, Wn. That is, V can be written as, we write C1, C2, Cn in row and U1, U2, Un in this column. If you multiply first row, first column, you will get this thing. Similarly, this V, we have written first row and this one column. But what is this? This is the transpose of the component vector of V with respect to basis B. The component vector, we recall, is a column. So transpose of that column is this row. Similarly, this is the component vector of V with respect to basis B dash and its transpose. So we have got two different representations of the vector V. So one representation is this, and another representation we have got is this. First one is with respect to basis B and second one is with respect to basis B dash. We shall equate these two representations of V and use this relation between the bases u1, u2, un and w1, w2, wn. So we get this one. So we have equated V is the coordinates of V with respect to B times the basis, and coordinates of V with respect to B dash and then the basis B dash. And we have this relation u1, u2, un is equal to this matrix, and the basis w1, w2, wn. Now substitute value of u1, u2, un, this vector, from this equation in this upper equation. So we get this result. The coordinates of V with respect to B into the value we have just substituted into coordinate of V with respect to basis B dash into W1, W2, Wn. Taking transpose both sides and using the fact that W1, W2, Wn is an invertible matrix, because the vectors here are linearly independent as it is a basis. So if I take a transpose and then multiply by inverse of this matrix, we get this result. Transpose of Aij into Vb is equal to transpose of this is component of V with respect to basis B dash. So we have got the following relation between the coordinate vectors of V. So we have written this matrix as A, B, B dash, and this V, B is same is equal to V, B dash. That's the coordinate of V with respect to B dash. So where the matrix A, B, B dash is equal to Aij is the transpose of the coefficient matrix of the system of equations 1. Remember that the system of equations 1 where we have written the elements of one basis with respect to the element of another basis as a linear combination. So that coefficient matrix transpose of that matrix is this Aij. Now suppose we wish to find the component of one basis with respect to the component of standard basis, or conversely, if we are given a component of a vector with respect to standard basis and we want to find the component of that vector with respect to another given basis, how we shall do that. So before that, let's see what I mean by a standard basis. The standard basis of Rn consists of unit vectors pointing toward the positive direction of the coordinate axis. So these are the standard bases. So this is x direction. This vector E1 is 1, 0, 0. It is pointing toward the positive direction of x-axis. The second is 0, 1, 0. It is pointing toward the positive direction of y-axis. And the third one is in the z direction 0, 0, 1. So similarly in Rn we have n such vectors having the ei is 1 at ith position and 0 elsewhere. So the collection e1, e2, en is the set of ordered set of vectors which is called a standard basis for Rn. So if we wish to transform the components of a vector V with respect to basis B to the components with respect to standard basis E, then we replace B dash by the standard basis E in the formula this. So the formula what we have got with respect to basis B and B dash, in that formula replace this B dash by the standard basis E, what we shall get. So this matrix A, B, B dash will be replaced by A, B, E. And notice that this matrix will be just a matrix B. So why this A, B, E is B? So notice that if you take any UI, it has a linear combination with respect to standard basis is this. But in EI, in E1, the first entry is 1 and rest is 000. In E2, the second entry is 1, the rest are 000. Similarly, in En, the nth position is 1 and rest everything is 0. So if you add up all these entries, you will get this vector. Ui is A1i, A2i, Ani. So what it means? So it means this important thing. Component of ui is same as the vector ui. So if you are using a standard basis and you want to write the components of a vector with respect to standard basis, then the vector itself is the component vector. So v is vb if b is the standard basis. So it means this vector, this matrix will be replaced by B. So we get VE is equal to B VB. So also notice that if we wish to transform the components of a vector with respect to the standard basis E to the components of the same vector with respect to another basis, then what we shall do? So देखिए पहले हमने क्या किया है कि अगर मेरे पास कंपोनेंट्स है विद रिस्पेक्ट टू सम बेसिस बी, तो मैं उसको कन्वर्ट करना चाहता हूँ कंपोनेंट्स इनटू द गिवन इनटू द स्टैंडर्ड बेसिस, तो मेरे पास ये फॉर्मूला है. अब मैं कहता हूँ कि सपोज आई हैव गिवन a vector whose components are written with respect to standard basis and I want to change the components of the same vector with respect to another given basis B. So what I will do is multiply by B inverse. So we get B inverse VE is VB. So these are components with respect to E and we convert them to the components with respect to vector B. So let's see now an example. So let B is this basis for the vector space R2 and V belongs to B is any vector. Notice that this vector V has representation with respect to basis B as V is equal to 5 by 3 into this basis vector say V1 plus 2 by 3 into another basis vector V2. So if you add, multiply and add component wise, you will see that the V is 3, 4. So now this V, I want to find its component with respect to the standard basis. So what are the components with respect to standard basis? So first we have VB is, these are components with respect to basis B. So use this formula. Components of V with respect to standard basis is VB multiplied by the matrix B. So the matrix B is the set of vectors, right? The set of vectors in columns. So first column, first vector, second column, second vector. Now multiply this matrix by this. So first row and first column, you will get 3, 4. So 3, 4 are components of this vector with respect to the standard basis on Z. Thank you very much.